So welcome to another one of our instructional videos for our new Chemistry Honors Flipped Classroom. This one we're actually going to watch in class, and I hope not to cringe while I watch it with you. But the idea here is to help you understand a bit more about the Flipped Classroom and what it can do. So I'm here on our Edit Me homepage. In fact, let me log out here. And then I'm going to go to Chemistry Honors. And what we're going to do today, and remember that I've put new material towards the top, I'm going to help you go through a walking tour of the periodic table. And by the end of this, we hope that you will create your own personal resource about the periodic table, something color-coded that can help you in our future classes. So I'm going to go over to our Chemistry Honors resources, and I have added something new called the Dynamic Periodic Table. This is a link to a web application that talks all about the periodic table. So let me click on that, and there we are. There is our periodic table. Right now I have it, maybe I can shrink it a little bit for you. Right now I have it kind of in all of its glory, all these colors shown here. And one might ask, and it's totally understandable, how could I possibly memorize all of this information? And the easy answer is, well, you can't. There's more information contained in this table, and in particular, at your fingertips through this web application than you could possibly ever come to know. And so the easy answer is we don't memorize it, and instead we use the periodic table as a tool. So let's talk about this particular site as an example of the periodic table and how it can help us. So the first thing that you'll notice is that in this space right here, whenever I hover over a particular element, its elemental box will show up. And what's included in that box is the element's name, in this case titanium, the symbol for the element, a capital T, a lowercase I. In fact, if I look at the other elements, you'll notice they always begin with a capital letter. And if another letter follows, that letter will always be lowercase, as in the case of beryllium, or chromium with its Cr, or manganese. Down here at the bottom, I have a really long number here. Seems pretty precise. This is the atomic mass. And this tells me how heavy manganese, as an example, is compared to other atoms on the periodic table. So manganese has a mass of about 55 grams per mole. And hydrogen, the lightest on the table, has a mass of only about 1. So manganese is about 55 times heavier per particle than is hydrogen. Also here, we have a number, and this is called the atomic number. It's telling me how many protons each atom has. And remember that that's the defining characteristic of an atom that makes it its unique element. And then we'll come to learn about this later. This is something about how the electrons are distributed around the atom and have to do a lot with bonding and the types of charges that manganese and other atoms might take on when they become ions. So you see colors everywhere, and that's because we have families. We call the columns families, and families bear a resemblance to one another. So here we have a family called the alkali metals. And the alkali metals are in the same column, and they're placed there because they have similar chemical reactivity. The same is true of the next column, which is the alkaline earth metals, also reasonably reactive metals. I'll skip over the lanthanoids and actinoids for a moment. In the middle, we have a big block, a very wide block of columns called the transition metals. And they're highly variable in terms of the way they behave. And then, because we don't have a better name for them, the post-transition metals are sitting over here, capped by aluminum, then gallium. Tin is in this group, so is lead and bismuth. If I click right there, you'll notice that the vast majority of the elements on the table, the ones now colored, are metals. So most of the known elements are metals and have metallic character. They are shiny and lustrous. They tend to donate electrons. They're good conductors of electricity. They can be pounded into shapes and drawn out into wires. All the things that metals can do. But if I go to nonmetals, you'll see that that's a relatively small subset of the elements on the table. And we have noble gases. Noble gases are non-reactive. They're headed by helium and neon and argon. We have the next group over called the halogens. And then because we don't have a very good name for them, some of the more common elements like carbon, nitrogen, and oxygen are placed in the other metal column. Now I skipped over the lanthanoids and actinoids kind of intentionally because they look like they've really been set outside of the periodic table. And you can see here that it looks like they should be inserted. So what does that look like? Well, if I were to come over here and click wide, you can see what the table would look like if those lanthanoids and actinoids had been inserted into the table. It becomes kind of cumbersome and unwieldy. So I'm going to unclick that. And one of the reasons why we tend not to represent the periodic table this way is that the bulk of the reactions and atoms and elements that we'll talk about are restricted to what we call main group elements. And so we'll talk mostly about the alkali metals, the alkaline earth metals, these metals here, just post-transition, and these nonmetals. And of course, something that bears mentioning are the hybrids, like boron and silicon and germanium. These are the metalloids, which have hybrid qualities somewhere between nonmetals and metals. If I click on any one of these elements, a dialog box attached to Wikipedia comes up. And in that, I can obtain more information than I can possibly use about that particular element, its history and its uses, where it's found in nature, and its physical and chemical properties. So you can see that there's a tremendous amount of information. So what's our goal? Our goal is to create for you an individual periodic table, color-coded by you, that can be used as a resource for you in class. I hope you enjoyed the video.